Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 24th, 2026, just 2 days ago. It introduces ArtiAgent, an automated system that synthesized a massive dataset of 100,000 flawed images, enabling smaller open-source models to beat GPT-5 at spotting visual defects. The paper is titled "See and Fix the Flaws: Enabling Vision Language Models and Diffusion Models to Comprehend Visual Artifacts via Agentic Data Synthesis." And as we'll see later, the implications for automatically fixing AI-generated images are really promising. And for those interested in the implementation, the authors have shared their code on GitHub. Figure 1 illustrates the core challenge. The top left panel highlights that even state-of-the-art diffusion models frequently produce structural artifacts, like duplication, where a hand has 6 fingers, or fusion, where objects merge illogically. Crucially, as the dialog bubble shows, standard vision language models often fail to notice these errors entirely. To solve this, Panel B introduces the ArtiAgent framework. Instead of relying on expensive human labeling, it takes real images and deliberately injects defects, like distorting a bear's nose or deleting a limb, to create a large-scale synthetic training set. This enables the downstream applications shown in the bottom row, such as accurate detection and automated image correction. So while Figure 1 introduced the problem, Figure 2 breaks down exactly which types of errors occur most often. It reveals that duplication is the leading artifact, making up 37% of the cases, followed closely by distortion at 34%. Fusion, where objects merge illogically, accounts for 20%, while omission is the rarest at just 9%. This breakdown is critical because it defined the 4 specific categories that the ArtiAgent needed to learn to synthesize. Well, having seen the types of flaws in Figure 2, Table 1 now quantifies how often they actually happen in modern models. It is striking that Stable Diffusion, 3.5 large, generates artifacts in 36% of its outputs, which is a significant portion. Flux Schnell follows at 28%. In contrast, Nano Banana demonstrates much higher stability with an artifact frequency of just 5%. These numbers confirm that structural defects are not solved problems, even for top-tier generative systems. So, having quantified the problem, Figure 3 displays the ArtiAgent pipeline designed to solve it automatically. The process splits into 3 coordinated agents. On the left, the perception agent starts by decomposing a real image, using grounding SAM to identify specific entities and sub-entities, like a surfer's face or hand. Next, the synthesis agent in the center takes over. It uses a toolbox of operations to introduce artifacts, such as distorting a face or duplicating a limb, and embeds them into the image using a technique called inversion injection. Finally, the curation agent on the right filters out low-quality outputs and generates the detailed text explanations needed for training. Alright, with the pipeline defined, Table 3 reveals the payoff. It compares standard methods against open-source models fine-tuned on the ArtiAgent data. The results are striking across all 3 tasks: detection, localization, and explanation. For instance, in binary detection on the left, the intern versus L model improved to 63% accuracy, actually outperforming GPT-5. Moving to the explanation scores on the far right, the gains are even larger, with the circa SS metric nearly doubling. This proves that synthetic training data can effectively teach smaller models to spot and describe complex visual flaws. Moving beyond detection metrics, Figure 8 demonstrates the practical payoff: automated image correction. Here, the ArtiAgent trained model acts as a critic, identifying flaws like the distorted hand in the top left or the corrupted eye of the frog in the top right. It then guides an in-painting pipeline to regenerate just those specific regions. The after columns show the results, where the hand becomes anatomically correct and the frog's eye looks natural again, proving the system effectively closes the loop on artifact repair. Wrapping up, 2 main points stand out. Synthetic data can effectively replace costly human annotation for detecting visual flaws, and smaller models trained on this data can actually outperform proprietary giants like GPT-5. This really opens the door for self-correcting generative systems. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.